My name is Harvey Dellin, and today I'll be talking about practice worksheet number 1 of absolute value. All right, so let's begin. So the first question is, in the absolute value brackets, 6x plus 12 is equivalent to 24. Right. So since this is an they're absolute values. The equation is an absolute value. There's two possible solutions for this equation, right? The equation could be equal to either positive 24 as normal, right? Or it could be equal to negative 24, as the absolute indicators will end up changing the negative 24 to positive 24 at the end of the equation. Okay, so now we make it equal for both equations. So we make two different solution steps. Right, so we have 6x is equivalent to 24 minus 12, right? So this is for 6x plus 12 is equivalent to 24, that solution. So 6x equals 24 minus 12, which becomes 6x is equal to 12, which becomes x is equal to 12 divided by 6, which means x can be equivalent to 2. That's to make the equation equal 24 right away. The second solution is to make 6x plus 12 equal to negative 24, right? So 6x plus 12 equals, if we move the 12 over, it becomes 6x equals to negative 36, right? Which becomes x is equal to negative 36 divided by 6, which is equal to x minus 6. So these two values are what x can be in this specific solution. Moving on to number 2. In the absolute value brackets, 6 minus 2x, and then out of the brackets, is equivalent to 14. So once again, we're going to make two solutions, and one that is equivalent to negative 14, and one that's equivalent to 14. So first, we're going to do the one that's equivalent to 14, which is 6 minus 2x is equivalent to 14. All right, so first things first, we're going to rearrange. So it becomes negative 2x is equivalent to 8, which becomes x is equivalent to 8 divided by negative 2, which means x is equivalent to negative 4. Second solution, we made it to equivalent to negative 14, and in this solution, we have 2x is equivalent to negative 20 once the 6 is rearranged, right? And the final answer becomes x is equivalent to 10 once rearranged. Okay, solution number 3. Number 3, once again, it's in the absolute value. The brackets is ax minus 2, right? Now, outside of the brackets, it's equivalent to 42, right? So once again, we're going to make it two possible scenarios where it's equivalent to 42 or where it's equivalent to negative 42. Beginning with the one where it's equivalent to 42, we have 8x minus 2 is equivalent to 42. Rearrange, you get 8x is equivalent to 44. Once again, rearrange so x is isolated. You get x is equal to 11 over 2 or 5.5. All right, second solution, we have 8x minus 2 is equivalent to negative 42. Right, we rearrange so it becomes negative 42 plus 2, which becomes 8x is equivalent to negative 40. We isolate the x by dividing the 8 with the negative 40, and we get x is equal to negative 5. Question number 4. Absolute value 2 over 3x plus 6, absolute value is equivalent to 2. So once again, we're going to make it equivalent to 2, a positive 2, a solution where it's equivalent to positive 2, and a solution where it's equivalent to negative 2. So for the first solution, we're going to make it 2 over 3x plus 6 is equivalent to 2. Right, we rearrange, becomes 2 over 3x equals negative 4. Right, and now we need to isolate the x. So we times the other side by 3 over 2, and we times both sides by 3 over 2, and we get x is equal to negative 6. Solution number 2. We have 2 over 3x plus 6 is equivalent to negative 2. Now 2 over 3x, we rearrange so it becomes equal to negative 8. Isolate for x, which becomes x is equivalent to negative 8 divided by 2 over 3, which means x can be equivalent to negative 12 as well. Now going back up to question number 5. This is, once again, absolute value 10 minus 3 over 4x, absolute value is equivalent to 16, right? Once again, two solutions. One's equivalent to positive 16, one's equivalent to negative 16, right? Beginning with the positive one first. 10 minus 3 over 4x, right? We're isolating the x, so we're going to bring the 10 to the other side, which makes it 3 over x. Negative 3 over x is equivalent to 6, right? Once again, we isolate for the x, which equals x is equal to 6 divided by negative 3 over 4, which means x is negative 8, is equivalent to negative 8. For the next solution, it's 10 minus 3x over, it's 10 minus 10 minus 3 over 4x is equivalent to negative 16. We rearrange so that the x is being isolated. We rearrange again, right? And so it gets x equal to negative 26 divided by negative 3 over 4, right? And we get x is equal to x is equal to 34.6, and that's a rounded figure. Okay, now on to question number 6. In this specific question, there's no solutions, as an absolute value cannot be less than 0 or equivalent to less than 0, right? So in the equation we have absolute value 4x minus 12, absolute value is equivalent to negative 36. That's not possible, so there's no solutions. Okay, now we're on to question set number 2. So the first question is, we're just comparing normal things. So it's 5x plus 9 is equivalent to 144. So rearrange so the 9 goes on the other side. All right, and we get x is equal to 30.6. Okay, on to the next equation. We get 5 bracket 3x minus 6 plus 9 is equivalent to 144. All right, we rearrange so it becomes equivalent to 135 because we move the 9 over to the other side. Then we rearrange again by dividing it by 5, so it becomes absolute value 3x minus 6 is equivalent to 27, right? And now we complete the two of the solutions, right? So we have 3x minus 6 is equivalent to 27, and equivalent to 27, and we have the other side where it's equivalent to negative 27. And now we isolate for x on both. So on the first one, it becomes 3x is equal to 33, and the x is equal to 11. The second one becomes 3x is equal to negative 21, and x is equal to negative 7. And that's after rearranging. Question number 3, it's 8x minus 3. Right, we rearrange, it becomes 8 over 7 minus 3, sorry, e is equivalent to 1. We rearrange, it becomes 8 over 7. X over 7 is equivalent to 4. And x is equivalent to 4.7. Sorry, it's x over 7 minus 3 is equivalent to 1. So we rearrange, we get x is equal to 28. For question number 4, we have absolute value 12x minus 8, absolute value divided by 7 minus 3 on the outside of the fraction is equivalent to 1. Right, so now we rearrange, we get this value right here, 12x minus 8 over 7 is equivalent to 4. Once again, rearrange, we times the 4 by 7, we times the fraction by 7. We get absolute value 12x minus 8 is equivalent to 7 times 4, which is equivalent to 28. Right, so now we have to do it for both solutions, where it's equivalent to negative 28 and positive 28. And we get that, we get x is equivalent to 3 for the positive 28 solution, and we get x is equivalent to negative 5 over 3 for the negative solution as we rearrange the equations, right, by isolating the x value. On to question number 5. This one's pretty basic. We have 2x over 3 minus 11. We rearrange so we isolate for the x. We have 2x over 3 is equivalent to 8. Right, now we isolate the x again by timesing the other side by 3 over 2, timesing both sides by 3 over 2, and we get x is equal to negative 4.5. On to question number 6, we have 2 over 3 absolute value of 2x minus 10 minus 11 is equivalent to negative 3 right here. So first things first, we isolate the absolute value, or the numbers in the absolute value. So basically we bring the negative 11 over to the other side, right? It becomes 8 on the other side, right? Once again, we isolate again. So we times both sides by 3.2 to get rid of the 2 over 3 on the left side, and we basically, or you could divide 8 by 2 over 3, same thing, right? And you end up getting absolute value 2x minus 10 is equivalent to 12, right? So now there's two solutions once again, as we know we've done before. One's equal to positive 12, one's equal to negative 12. We basically isolate for the value of x. So on the first one, we rearrange so the 10 comes over to the other side, right? It becomes 2x is equivalent to 22, right? Which becomes x is equivalent to 22 divided by 2, which means x is equivalent to 11. All right, and the second solution is that 2x minus 10 is equivalent to negative 12, right? So it becomes 2x is equivalent to negative 2 once we rearrange to isolate for x. And once we rearrange again, we get x is equal to negative 1, because negative 2 divided by 2 is equal to negative 1. Okay, on to the next solution, number 7. Yep, number 7 right here. So, which is 4x minus 5 divided by 3 is equivalent to 9. Right, we isolate for x value. We end up getting 4x minus 5 is equivalent to 27. Once again, isolate for the x value by bringing the 5 over to the other side. We have 4x is equivalent to 32. And finally, x is equal to 32 divided by 4, which means x is equivalent to 8. All right, for question number 8, we isolate for the absolute, or the numbers in the absolute value. So first things first, we times the fraction by 3 on both. We times by 3 on both sides, right? Which becomes 4. Absolute value of 8x minus 16 minus 5 is equivalent to 27. Right now we rearrange so that we plus 5 on both sides, which gives us 4. Absolute value of 8x minus 16 is equivalent to 32. And now we divide 4 on both sides, which goes absolute value of 8x minus 16 is equivalent to 8. Once again, two solutions, positive 8, negative 8. Right, we rearrange for x in the first solution. We get 8x is equal to 24 once we bring 16 over to the other side. And we find once we divide both sides by 8, we get x is equal to 3. For solution number 2, we have 8x minus 16 is equivalent to negative 8. Right, we bring 16 to the other side, which makes it 8x equal to 8x is equivalent to 8, and we isolate for x again, which becomes x is equal to 8 over 8, which becomes x is equal to 1. Question number 9. We have absolute value 4x minus 5 plus 15 is equivalent to 36. Right, so basically we rearrange, so we bring the 15, we minus 15 on both sides. We get 4x minus 5 is equivalent to 21. Right, so we do solution number 1, where it's equal to its positive value, which is 4x minus 5 is equivalent to 21. Rearrange to isolate for x, so we bring we add 5 on both sides, because 4x is equivalent to 26. Divided by 4 on both sides, x is equivalent to 26 divided by 4. X is equivalent to 6.5. Solution number 2 is equivalent to its negative value. Basically, we rearranged the thing by plussing 5 on both sides, yep, which equals 4x is equal to negative 16, right? And we divide it by 4 on both sides again, which means x is equal to negative 4. All right, continuation of the question set 2. We have question number 10, which is, yeah, right here, 6 absolute value 3x minus 12 minus 5 is equivalent to 49. We rearrange by adding 5 on both sides, becomes 6 times the absolute value of 3x minus 12, which is equivalent to 54. We divide both sides by 6, and we get the absolute value of 3x minus 12 is equivalent to 9. All right, so now we have two solutions where it's equivalent to 9 and negative 9. We rearrange for both. So for the positive solution, we end up getting x is equivalent to 7. For the negative solution, we end up getting x is equivalent to 1 by isolating for the x value. Okay, question number 11. We have 5x plus 7 divided by 11 minus 8 is equivalent to negative 6. We rearrange by adding 8 on both sides, which becomes 5x plus 7 over 11 is equivalent to 2. Right, now we rearrange by timesing both sides by 11. We have 5x plus 7 is equal to 22. Rearrange once again to isolate for x, which becomes 5x is equal to 15. And now we divide both sides by 5, and we end up getting x is equivalent to 3 as our answer. Question number 12, we have 5 times the absolute value of 6x minus 15 plus 7 divided by 11 minus 8 is equivalent to negative 6. Basically right here we're isolating for the absolute value, the numbers in the absolute value. So first things first, we times both sides by, and we add 8 on both sides, then we times both sides by 11, right, which will give us this, and then we minus 7 from both sides, which gives us this, and then we divide 5 on both sides, which will give us the value of absolute value of 6x minus 15 is equivalent to 3. Once again, two solutions, right? Positive solution is equivalent to 3, negative solution which is equivalent to negative 3, right? We isolate for both. So for this one, we isolate first. We get 6x is equivalent to 18, right? 18 divided by 6 is equivalent to 3, so x is equivalent to 3. Solution number 2, we have 6x minus 15 is equivalent to negative 3. Right, it becomes 6x is equivalent to 12, right, which becomes x equivalent to 2. Question number 13, we have 5 over 8, right? Absolute value of 2x minus 4 plus 4 is equivalent to negative 9, right? Once again, we isolate by subtracting 4 on both sides. Yep, we get 5 over 8. Absolute value of 2x minus 4 is equivalent to negative 13, right? We once again isolate for the absolute value, the numbers in the absolute value, and we end up getting the absolute value is equivalent. The absolute value of 2x minus 4 is equivalent to negative 20.8, and this will have no solution as an absolute value cannot be negative, as stated beforehand. Okay, now we're on to question set number 3. I'm just going to speed through these as they're very similar to the previous question set. So our equation is 3 times the absolute value of 6x minus 12 plus 5 is equivalent to 59. First things first, we rearrange according to BEDMAS, right? So we bring this at negative 5 on both sides. We get this number, right? And then we divide both sides by 3, which will give us 6x minus 12 is equivalent to 18. So once again, we have to make it two different solutions where it's equivalent to positive 8, two possibilities where it's equivalent to 18 and where it's equivalent to negative 18. We rearrange for both. For the first one, we get 6x is equivalent to 30, x equivalent to 30 over 6, x equivalent to 5. Second solution, we get 6x is equivalent to negative 6, x is equivalent to negative 6 divided by 6, and x is equivalent to 1. Excuse me. On question number 2, we have 2 over 3 times the absolute value of 10x plus 2 minus 7 is equivalent to 17. We rearrange by adding 7 on both sides, which gives us this. And then we rearrange by timesing both sides by 3 over 2, which will give us the final thing, absolute value, what is equivalent to. So absolute value of 10x plus 2 is equivalent to 36. Once again, two solutions. For the first solution, we get 10x is equivalent to 34 once we rearrange to isolate for the x. And once we isolate it again, it becomes 34 divided by 10, which means x is equivalent to 3.4. Solution number 2, we have 10x plus 2 is equivalent to negative 36. We isolate for x, so we subtract the both sides by 2, which becomes 10x is equivalent to negative 38. Isolate for x, divide both sides by 10. X is equivalent to negative 3.8. Question number 3, negative 3 times the absolute value of 16x minus 8 plus 3. You isolate for the numbers in the absolute value, so it becomes negative 3 times 16x minus 8 is equal to 120. Right, divide both sides by negative 3. You get the absolute value of 16x minus 8 is equivalent to negative 40. In this case, as it's a negative number, absolute values cannot have negative numbers. There's no solutions possible. Question number 4, you have 3 times the absolute value of 4x minus 12 divided by 5 minus 34. First things first, you isolate by adding both sides. You add 34 to both sides. Right? Once you added 34 to both sides, you should times by 5, right? And then you should get 4x minus 12 is going to 51.6. Solution number 1 will give us x equivalent to 15.9. Solution number 2 will give us x equivalent to negative 9.9. Question number 5, we have the absolute value of 3x minus 3 divided by negative 11 is equivalent to negative 3. Right, we get the absolute value of 3x minus 3 is equivalent to 33. So solution number 1, we get 3x minus 3 is equivalent to 33. 3x is equivalent to 36, and then x is equivalent to 20. X is equivalent to 12. This is all by isolating for x. Solution number 2, we get 3x minus 3 is equivalent to negative 33. 3x equals to negative 30, and x equals to negative 10. For question 6, it's 3 times absolute value of 4x minus 12 over 5 minus 4 is equivalent to 20. Right, we end up getting 3 times 4x minus 12 over 5 is going to 24. Right, once again, we isolate again by timesing it by 5, right, and then we divide it by 3, which will give us the final. The absolute value of 4x is minus 12 is equivalent to 40. Solution number 1, right, we have the possibility of where it's equivalent to positive 40. We isolate for x. It becomes 4x is equivalent to 52. X is equivalent to 13. Solution number 2, it becomes 4x minus 12 is equivalent to negative 40. And 4x equals negative 28, which ends up x, if we keep isolating, x is equal to negative 7. Question number 7. You have 3 times the absolute value of 7x plus 21 minus 1 divided by 2 is equivalent to 52. All right, 3 times 7x plus 21 minus 1 is equivalent to 104. 3 times the absolute value of 7x plus 21 is equivalent to 105. Right, and then the absolute value of 7x plus 21 is equivalent to 35. For solution number 1, whereas the possibility of equivalent to positive 35, we basically isolate for 7x plus 21 equal to 35. We isolate for the x here, which will give us 7x is equivalent to 14 and x is equivalent to 2. And for solution number 2, we once again isolate for x, where in this case is equal to negative 35. This will give us 7x is equivalent to 56. And yeah, 7x is equal to negative 56. Sorry for that mistake. And x should be equivalent to negative 8 in this case. Missed the negative sign there, but yeah, that's what it should be equivalent to. All right, for number 8, it should be 5 times 12x minus 4 plus 8 divided by 4. All right, is equivalent to 72. We isolate, so that's the absolute. We only have the absolute value. All right, that becomes step by step right here. And that gives us 12x minus 4. The absolute value of 12x minus 4 is equivalent to 56. Once again, two possible solutions where it's equivalent to is positive and it's negative. So we have 12x minus 4 equal to 56. It becomes 12x equal to 60. And if we keep isolating for x, it becomes x equal to the 5. For solution number 2, we have 12x minus 4 is equivalent to negative 56. We once again isolate. It becomes 12x is equivalent to negative 52. All right, which becomes x is equivalent to negative 4.3 rounded. Okay, on to question number 9. We have negative 2 times the absolute value of 8x minus 4. Right, this equals 18. The absolute value of 8x minus 4 is equivalent to 44 once we rearrange this equation. Two solutions where it's equivalent to positive 44 and negative 44. All right, we end up isolating for x, so it becomes 8x is equivalent to 48 and x equivalent to 6. And the second solution becomes 8x is equivalent to negative 40 and x is equivalent to negative 5. Question number 10, it becomes 2 over 3 times the absolute value of 2x plus 3 minus 12 is equivalent to negative 6. We isolate so that we only have the numbers in the absolute value. They end up equaling, the absolute value of 2x plus 3 ends up equaling to 9 once we rearranged. Once again, two possibilities where it's equivalent to positive 9 and negative 9. We isolate for x in both. So 2x plus 3 is equivalent to 9 becomes 2x equals to 6. Right, and it becomes x equivalent to 3. Solution number 2 is 2x plus 3 is equivalent to negative 9. We rearrange, it becomes 2x equivalent to negative 12. We isolate for x is equal to negative 6. Question number 11, we have 4 times the absolute value of 5x minus 10 plus 23. We rearrange so that we only have the numbers in the absolute values, in the absolute value brackets. This will give us 5, basically right here, we get 4 times 5x, 4 times the absolute value of 5x minus 10, which goes 26. All right, we divide both sides by 4. All right, which is absolute value of 5x minus 10 is equivalent to 6.5. Once again, two possible possibilities where it's equivalent to 6.5 positive and negative 6.5. We rearrange and isolate for x. So this gives us 5x is equivalent to 16.5 and then x is equivalent to 3.3. And this solution number 2 will give us 5x is equivalent to 3.5 and x is equivalent to 0.7. Question number 12. We have 3 times the absolute value of 12x plus 8 divided by 8 minus 7. Once again, we rearrange so that we only have the numbers in the absolute value. So we go step by step using according to BEDMAS, and we end up getting absolute value of 12x plus 8 is equivalent to 16. Two possibilities where it's equivalent to positive 16 and negative 16. First, for the positive 16, if we isolate for x, we get 12x is equivalent to 8, and then we get x is equivalent to 2 over 3. This is done by isolating. Solution number 2, we get 12x plus 8 equivalent to negative 16. All right, so it becomes 12x is equivalent to negative 24, and becomes x is equivalent to negative 2. On to question number 13, we have absolute value of 7x plus 14 minus 1. That's outside the brackets with the minus 1. Divided by 5 is equivalent to 25. First things first, we times it by 5 to isolate to remove the fraction. So it becomes the absolute value of 7x plus 14 minus 1 is equivalent to 125. Rearrange so that we only have the values in the absolute value brackets. So it becomes 7x plus 14 is equivalent to 126. Solution number 1, it's where it's equivalent to the positive value of 126. It becomes 7x is equivalent to 112. And it becomes x is equivalent to 16 once you isolate for x, because 112 divided by 7 is equivalent to 16. Solution number 2, it becomes 7x plus 14 is equivalent to negative 126. It becomes 7x is equivalent to negative 140. And it becomes x is equivalent to negative 20, as negative 140 divided by 7 is equivalent to negative 20. Question number 14. We have 5 times the absolute value of 12x minus 4 plus 8 divided by 4 equivalent to 72. Once again, we rearrange like we've done in every other question before so that we only have the values in the absolute value. So we end up getting the absolute value of 12x minus 4 is equivalent to 56. And once again, two possibilities where it's equivalent to positive 56 and negative 56. For the positive 56, we rearrange and isolate for x. So it becomes 12x is equivalent to 60 and x is equivalent to 5. And for the other solution, it becomes 12x is equivalent to negative 52, and the x is equivalent to negative 4.3 rounded. Question number 15. So it's 2 times 6x minus 24 divided by 9 plus 5. We rearrange, so we end up for the numbers in the absolute values, so that we only have the numbers for the absolute values on the left side, and we basically get the absolute value of 6x minus 24 is equivalent to 54. Once again, two possibilities where it's positive 54 and negative 54. For the first solution, we rearrange to isolate for x, so it becomes 6x plus 6x. 6x is equivalent to 78, right? 78 divided by 6 is equivalent to 13. All right, for the second solution, once again, we isolate for x, so it becomes 6x is equal to negative 30. X is equivalent to negative 30 divided by 6, and x is equivalent to negative 5, equivalent to negative 5. Okay, finally, on to question number 16. This question is 6 times the absolute value is 6x minus 9 plus 4 divided by 5 plus 11 is equivalent to negative 5. Once again, we isolate. So first things first, we move the 11 over, so it becomes minus 11 from both sides, and then we times 5 by both sides, so we get 6 times 6x minus 9 plus 4 is equivalent to negative 80. In this step, we minus 4 from both sides first, which will give us negative 84, and negative 84 divided by 6 is equivalent to the absolute value of 6x minus 9 is equivalent to negative 14. So since this is equal to a negative number, there's no solutions possible, as this absolute value. An absolute value cannot equal a negative number. Okay, on to question number 4. So now we're dealing with inequalities, right? So for the first question, right, we have the absolute value of 5x is greater than 30, right? So solution number 1 is we take 5x, we isolate for x basically, right? So it becomes 5x divided by 5 is greater than 30 divided by 5, so it becomes x has to be greater than 6. And for a second solution, since it's absolute value, you have to look at the negative possibility as well, right? And you have to switch the inequality sign, as if you switch the value on the other side, just sign, you have to switch the inequality sign. You have 5x over 5 is less than, right, negative 30 over 5, which becomes x is less than negative 6. So on the graph, x can be either less than negative 6 as shown here, or greater than 6. It cannot be in between. Okay, question number 2. Absolute value of negative 7x has to be less than 14. We have two solutions again, where it's first solution is we isolate for x again, so it's negative 7x divided by negative 7 is less than 14 divided by negative 7. So it ends up, since we're dividing by negative 7, the inequality sign changes to the other side. We end up becoming x is greater than negative 2. And for solution number 2, we have negative 7x divided by negative 7 is greater than negative 14 divided by negative 7. And once again, since we're dividing by a negative number, the inequality sign will change its direction. So it becomes x is less than 2. And then here on the graph shows that x can be between negative 2 and 2 and nowhere else. For question number 3, this doesn't work because an absolute value cannot be equivalent to a negative value, a positive number. It must be equivalent to a positive number. It cannot be equivalent to a negative value. All right, so we go on to question number 4. Question number 4 is the absolute value of 5x minus 10 is greater than and equal to 15. So both solutions, the first solution is 5x minus 10 is greater than or equal to 15. Right, we isolate for the x, so it becomes 5x divided by 5 is greater than or equal to 25 divided by 5. Since we're dividing by a positive number, the inequality sign does not change, so it ends up becoming x is greater than or equal to 5. Solution number 2, since we change the sign of negative 15, the inequality sign changes, so we have 5x minus 10 is less than or equal to negative 15, right? We isolate for x, and we end up getting x is less than or equivalent to negative 1 on our, and then we graph this, right? The x can be all the way up to negative 1, and x can be greater than 5. So that's on our graph. Right? Any value greater than 5, any value less than negative 1. On question number 4, we have 4 times the absolute value of 3x minus 6 minus 9 is greater than 27. So we end up getting, I'm just gonna speed through this. Ends up isolating that 3x minus 6 is greater than 9. Solution number 1 will give us x is greater than 5. Solution number 2 gives us x is less than negative 1. On the graph is shown here that x cannot be between negative 1 and 5. All right, question number 6. Negative 6 times 4x, the absolute value of 4x minus 12 minus 11 is greater than or equal to negative 131. We isolate for the absolute value numbers, which is what we get here. We do both solutions where it's equivalent to the normal, the negative possibility and the positive possibility, and we end up getting x has to be less than or equal to 8.04, and x has to be greater than or equal to negative 2.04, and that's shown on the graph here. Question number 7, we have 3 over 4 times the absolute value of 8x minus 16 plus 11 is less than 17. We isolate, so it becomes 8x minus 16. It has to be less than 8, right? Both solutions where it's negative 8 and 8. For the first solution, our answer is 8 is less than 3 by isolating for x. Second solution is x has to be greater than 1, or x has to be less than 3, and then x has to be greater than 1, and that's shown in the graph here, right? Once again, we take this equation, we isolate, so it becomes the only numbers in the absolute value brackets are left. So it becomes the absolute value of 5x plus 10 has to be greater than 20. Now we have two solutions where it's has to be greater than 20 and has to be less than negative 20. We isolate for x in both, so we get x has to be greater than 2 and x has to be less than negative 6, as shown in the graph here. Question number 9, we have 5 times the absolute value of 12x minus 8. Minus 8 divided by 4 has to be less than or equal to 33. We isolate so that we only have the numbers in the absolute value brackets. So it becomes the absolute value of 12x minus 8 has to be less than or equal to 28. We do it for both possibilities, and we isolate for x. So here are the steps. X has to be less than or equivalent to 3. And for this, the other possibility, x has to be greater than negative 1.6, as shown on the graph here. X can only be between these two values. Number 10, we have 3 times 8x plus 16 divided by 4 minus 35 has to be greater than negative 5. All right. 1 second, I'll be back. Okay, sorry. We're basically isolating for the absolute values. Becomes 8x plus 16 has to be less than or equal to 40. Solution number 1, we get x has to be less than or equal to 4.25, and for solution number 2, we get x has to be greater than or equal to negative 7. And that's shown on the graph. So x can only be between these 2 points. Question number 11, negative 5 times the absolute value of 14 minus 7x plus 6 is less than equal to 41. We isolate for the absolute values. Once again, we get absolute value of 14 minus 7x has to be greater than or equal to negative 5. So we do for both possibilities, the positive possibility and the negative possibility. You have 14x. Basically, this is what we get. We get x has to be less than or equal to 1.29, and we have to x is greater than 2.7, and it's shown in the graph. All right, we just continue doing this for the other questions as well. First things first, isolate for the values in the absolute value. So we get 15 minus 2 over 3x has to be less than equivalent to 11, right? Yeah, it has to be less than equivalent to 11. So for solution number 1, we isolate for x, and we get x has to be greater than or equal to 6. For solution number 2, we isolate for x, and we get x has to be greater or less than 39, and this is shown in the graph. 13, right? Once again, we isolate for the values in the absolute value brackets, so we get 7x minus 28 is less than 14. Now we do it for the two possibilities, and we isolate for x in both. So we end up getting x has to be less than 6, and x has to be greater than 2, and we show this in our graph. Right? Question 14, we have 4 times the absolute value of 5x minus 2 plus 3 divided by negative 5 has to be greater or equal to negative 15. Alright, we isolate for the absolute value, which comes the absolute value of 5x minus 2 has to be greater than or equal to 18. Alright, for solution number 1, we get 5x minus 2 has to be greater than or equal to 18. We isolate, we get x has to be greater than or less than or equal to 4. Sorry, it's less than to equal to. I've been reading the sign wrong. And for solution number 2, we get x. By isolating for x, we get x has to be greater than or equal to 3.2. Right, so that's shown in the graph here. Question number 15, once again, we isolate for the absolute value numbers. Right, this will end up giving us the absolute value of 2x minus 8 is greater than 5. And now we write the two possible solutions for the two possible possibilities, and we isolate for x in both of them. So for the first one, where it's greater than 5, we end up getting x is greater than 6.5 by isolating for x. And for the second one, where it's less than negative 5, we end up getting x is less than 1.5. Right, so this is wrong. It should be on the outside, and that should be on the outside. Sorry for that, minor mistake during the graphing process. And now for question number 16. Once again, we isolate for the absolute values. We have 10x plus 5 has to be less than or equivalent to 15. Right, we have solution number 1. We get x has to be less than or equivalent to 1. And as for solution number 2, we get x has to be greater than or negative 2 or equal to negative 2. Right, so it can only be in between negative 2 and negative 1. Right, and for question number 17, there's no solutions, as once we isolate for the absolute values, it becomes 6x minus 24 is less than negative 36. No solutions. Question number 18, we once again isolate for 6x minus 9 has to be greater than negative 22.3. Right, we get x has to be greater than or equal to negative 22. Right, and the 6x has to be greater than 22.3. 6x has to be, yeah. And basically, x can be only between these 2 points, and that's it. One sec. Divided by 6. Less than or equal to 31.3. Greater than 5.2. Actually, yeah, it has to be equivalent in between these 2 points. Okay, it cannot be outside of them. Okay, thank you for listening to my explanation of my worksheet.